In this video, we are going to study what is exactly a hydrograph is and how this hydrograph is useful to find out the runoff value for the given catchment area. Hydrograph is nothing but a graph which is showing a variation of a discharge with respect to time at particular point of a stream. If we want to find out a runoff value or we want to find out the exact quantity of a water at the particular point in the stream or in catchment area, so this hydrograph plays an important role. So how we can produce that hydrograph? By plotting the graph against the discharge versus time. It shows the time distribution of total runoff at the point of a measurement, as runoff includes the contribution from surface runoff, subsurface runoff, and groundwater runoff base, or it is also called as a base flow. We know that we had already studied in a runoff, types of a runoff. We have a surface runoff, we have a subsurface runoff, and we have a base flow. So, contribution of these three runoff gives you the total amount of runoff which is flowing overall over the catchment area. So for finding out this runoff, we have to plot the basic hydrograph, which is also known as a storm hydrograph, or as well as it is also called as a flood hydrograph. The factors affecting the hydrograph at place being a complex and interrelated. Means what? The intensity, sometimes the intensity of rainfall varies from time to time. Sometimes it varies at the places. Then the catchment area is too small, is too big. Then the sources that are through which the water is carrying out and which is stored in the catchment area, that might be different. So because of all these factors, this hydrograph generation, it becomes complex and interrelated. What happened? Sometimes a basin may not produce exact two equal hydrographs with the two similar precipitation. If we have the same precipitation value for the two for a same single basin, but we can't say that we got the exact value of a hydrograph, as well as it cannot be held or it cannot be give us same two same hydrographs for the two basins of same drainage area which is having a similar precipitation. So because of this reason or because of this factor, sometimes the hydrograph may be a complex one. So, hydrograph, we know that this hydrograph is generated from the runoff, and the runoff which is generated from the precipitation is resulting from either an isolated storm or a series of a consecutive storms, which is also known as a complex storm. So, the hydrograph sometimes it may be produced from a single storm. Storm means a flood duration, a duration that gives us, it tells us that much intensity of a rainfall occurs throughout this duration. So this is called as a storm. So we have a individual storm or we have a consecutive storms also. So the hydrograph which are resulting from the isolated storm is known as a single peak hydrograph, and the hydrograph which is resulting from the consecutive uh, storms is known as a complex hydrograph. So now let's discuss about the component of a single peak hydrograph. So basically we have a three components with us. First is the rising link, then the peak and the recession link. So you got or will get the final idea by observing this diagram. You can see here, this shows the single peaked hydrograph which is resulting from an isolated storm. You can see here the rainfall hydrograph along with the infiltration curve. It is also showing on the top of this hydrograph. We had already studied in the methods of finding out the runoff. We are also using, or we can use the infiltration curve with the including or emerging with the hydrograph. So here we are representing this effective rainfall hydrograph picture. Then essentially This hydrograph, a single peaked hydrograph, have a three component. The rising limb, you can see the point A up to the point B. It is nothing but a rising limb. Then point B, P, C is showing us a peak point or a crest of a segment. And again from point C up to the point D, it is nothing but a recession limb. So let's see what is exactly a rising limb. But before this, if you can see this, there is a depression curve or there is a concave curve before the point A. Why it is happening? See, in the early period of a storm, there are a certain initial losses. As we know that we had already studied in irrigation part also. When we are going to supply a water before a sowing period, when we want to cultivate the ground, so we have to lose that soil and we have to give certain amount of a water for loosening purpose. So what happened because of this loosening method or loosening process, through the pores and through the voids of the soil, the certain amount of a water can be filled into this voids. And after some period, if the plant needs, after sowing, if plant needs extra amount of water, then only application of a minor watering we can take the production of a plant and production of a crop. So this will happen in a this already happen in a irrigation system. So here also you can see in the early period of a storm there are initial losses as well as a high infiltration losses. The saturation of up to until the infiltration capacity of the soil fulfills. Till that till that point only the infiltration losses may occur. So the high infiltration losses are occur and hence the discharge rises slowly. So as the time increases, after some certain time interval, the initial losses stop and the infiltration rate also decreases. So after this point, this portion and we can say that this rising limb will start uh, to increase in an ascending portion of a hydrograph. So what exactly it indicates us that it indicates the increase of discharge due to the gradual formation of a storage in the channels existing in the area and also over the watershed's surface. And this rising limb is also known as a concentration curve. See, due to this, more and more discharge from the distant parts reach the basin outlet, and the point A. Then point A is starting point, and B is the point of inflection. The shape of this rising dip is controlled by the characteristic of a basin as well as the duration and intensity of and as well as the uniformity of the rain also. So initial portion of this rising curve, it is in a concave portion, and we had already studied and we had already discussed that this concave shape is generally happened because of the greater losses of detention, surface detention, evaporation, percolation, infiltration, initial losses of rainfall, and as well as the heavier concentration of area between adjacent isochrones is laid between middle and upper part of the watershed. So this is the first component, that is a rising part, which is starting from a point A and which is end up to a point B, which is known as a point of a inflection. So now we have this is known as a point of a inflection on rising limb. Okay, we have another point of inflection. You can see the point C is also known as a point of a inflection, but it is it on the recession limb. Now the peak or crest segment. See point B, E, and C. This is nothing but a peak or crest segment. See, it includes the part of the hydrograph from the inflection point on the rising limb up to the inflection point on the recession limb. This crest segment is one of the most important component of the hydrograph. Why? Because it indicates the peak flow rate. Obviously, it gives us the maximum amount of a discharge according or with respect to the time. The peak represents the arrival of a flow at the outlet from all the parts of the basin. For a large catchment area, the peak flow occurs after the cessation of a rainfall, and the time interval between the center of a mass of a rainfall to the peak is controlled by characteristics of the basin as well as the storm characteristics. See, the peak may be sharp or flat depending upon the rainfall catchment characteristics. So, this section and this shape is generally affected and is generally controlled by the characteristics of the basin, the area of a basin, then the soil characteristic, then the geological formation of the basin, as well as the storm characteristics, means the duration, intensity, uniformity, etc. That all types are affected on or this all factors are affected on this shape of the peak area or the crest segment area. So the multiple peak complex hydrographs in a basin. See, we know that multiple peak means what? We have a also we have a consecutive storms with us. We have a different intensities of storms having a different time interval or sometimes having the equal time interval. So the multiple peak complex hydrographs in a basin can occur when two or more storms occur in a close succession. The point of inflection represents, see, the point of an inflection means what? It represents the change point of a contribution of the catchment to the channel system. It is the change point. See, from the P, uh, this section and this component will be transferred into a P point up to the C point, and after the C point, up to the D point, this component will be declared as a recession limb. So the point of inflection is nothing but a change point of a contribution of a catchment to the channel system. The end of a crest segment corresponding to the inflection point C marks the time when direct runoff from the overland flow into a stream outlet ceases. The point of inflection represents the condition of a maximum retention storage, means what? The depth of a water built up over the land surface area. So the second component part, which is having a important section and which is having the more importance. Now let's proceed to the recession limb, the third component of this hydrograph. So the recession limb, you can see this recession limb again. It is in a descending order. It is hence it is called as a recession. See, it extends from the point of an inflection, that is point from the point C of the crest segment to the point D. The point D, it is nothing but a point of a commencement of the natural groundwater flow. This recession limb indicates the storage contribution from surface storage, includes both surface as well as the channel storage, etc., and interflow and groundwater flow. So this surface storage, the line that's showing and the point, the D point, which showing here in the hydrograph, it includes the interflow, it includes the base flow, it includes the surface flow. The three contribution of a runoff gives us the point of a commencement, and it indicates the point of a commencement. Since the depletion of this retention storage takes place after the cessation of a rainfall, the shape of a recession curve depends only on the characteristics of a basin, and it is independent of a rainstorm characteristics. The recession curve can be considered as a rate of a discharge resulting from the draining of process, and it can be found out by using the Barnes equation. The discharge at any time interval q is equal to the discharge at the point of inflection, which is occurred at the point C, multiplied by the recession constant. And this recession constant, its value varies according to the characteristics of the basin, but generally it can be taken as less than the unity. This is important. We can say that these are the important components. Here, the time parameters are also used in hydrograph analysis. So we have generally we have a effective time duration, which gives us the net duration of a precipitation during which rainfall rates are more than the infiltration rate. Then we have a lag time. It is a time interval between the center of a mass of a net rainfall and the center of mass of a runoff hydrograph. So the T, it is denoted by the TL. You can see here that TL is represented and it is shown in the hydrograph also. The center of the mass and the mass of the net rainfall, which is showing in the effective rainfall hydrograph diagram, and the center of a mass of a runoff hydrograph. It's known as a lag time. Time to peak, it is denoted by the TP, and you can see it is a difference between the interval between the center of mass of a hydrograph and the commencement point and the starting of a rising limb. This distance between or the interval between this is known as a time to peak. Then the time to concentration, which is denoted by a TC. You can see above the TL, there is a TC, that is the time of a concentration. See, it is defined as the travel time of a water particle from the hydraulically most remote point in the basin to the outflow location. Then we have a recession time also. You can see at the uppermost section, the TR, it is denoted by a TR. It is duration of direct runoff after the end of effective rainfall duration. Then we have a time base of a hydrograph at the base and at the lower part of this hydrograph. You can see here a TB. It is denoted by a TB. It is time from which direct runoff begins, means from the point A, to the time when it stops, means at the point T. So the time interval between the point A and point D means the start of the direct runoff and end of a runoff. It is called as a, this is all about the components of a hydrograph. Thanks for watching this video.